Okay, here's another example. This one uses the arbitrary graph. It happens I got this one from another textbook, but we have the same thing in same sort of problem in our textbook, and I want to show you how this one is done. I also want to note that you can use the fun hardware that I'm using. This all belongs to the college, and you have the same right to use it that I do. What you need to do is go to the TILT office. I forget what TILT stands for, something to do with technology. And this is approximately room 342, something like that. So if you like to play with fun stuff and computers, they really have a lot of fun stuff that you can do. You can make movies with special effects, you name it. They have a lot of good things. Okay, so suppose that this function that we see here is f of x, and we want to make a new function out of it by adding 2 outside the parentheses like that. So this will be a change to all of the y values. I don't know what the function is, but some of the values are called out very clearly. And so for those, I'm going to add 2 units to each one and connect the dots. And there's f of x plus 2, a change outside the parentheses only, because this plus 2 is outside the parentheses, and what I mean to say is a change to the y values only. All the x values stay exactly where they were. Now I can do the same thing. Suppose that g of x is f of x minus 3. This time the subtraction is inside the parentheses, and remember that the horizontal moves, which are all inside the parentheses, go sort of contrary to the way that you think that they should. Well, the way that I think they should. So if we subtract inside the parentheses, then we're going to move to the right, not to the left. Like so. So this is our inside the parentheses change with f of x minus 3. Okay, suppose that g of x is 2 times f of x. This is outside the parentheses. Ooh, that doesn't look so good. Outside. So it changes y values. Okay, so what I'm going to do is multiply y values. This one, 0, stays the same. This y value, positive 2, goes to positive 4. This 0 stays the same. That 0 stays the same. And negative 4 should go to negative 8, but that's off the screen. Here I have a negative 3, and I can do the negative 6's. So my parabola, it's as though it was grabbed in the middle and yanked away from, stretched away from the the horizontal axis. So y values only change in this case. Okay. A reflection. This reflection is outside the parentheses. So since it's outside, I change y values only. And I'm going to leave the x values alone. 0 multiplied by negative 1 is still 0. 2 multiplied by negative 1 is negative 2. I've got a 0 that stays in place there. A third 0 that stays in place. This negative 4 becomes positive 4. The negative 3's become positive 3's. Okay, so this is a reflection around the horizontal axis. So it's as if I had a wire running through the zeros and I twirled it in my fingers. That's how I always think of it. Okay, now let's put the multiplication by negative 1 inside the parentheses. So when it's inside, x values are changed and y values stay the same. Okay, so this x at 4, 0 goes to negative 4, 0. Negative 2, negative 4. The 0 and the x stays the same. This negative 2 becomes a positive 2. The negative 5 becomes a positive 5. And I copy the shape. So now the wire runs through the origin from above, and my horizontal reflection is a reflection around the vertical axis. This exercise becomes more interesting the more changes we throw in. So let's do a change that makes two changes at once. Except we're not going to make them both at once. We are going to make them serially. And our series is always going to begin as close to x as we can. So step 0 is the graph that we see here. Our first move is going to be the one closest to x, so we will move right 3 units. And then we will move up 2 units. Okay, so I usually do this in stages, I guess, because I like taking things at a measured pace rather than doing it all at once. Now, when we get through with this, you may say to yourself, well, it would have been the same if I had moved it up 2 first and then over 3. And to that I can only say, trust me, there's going to come a time when it will make a difference the order in which you do these. Okay, so I have moved to the right 3 and up 2. Where problems typically occur if you change the order of things is when you have multiplications as well as additions and subtractions. And then if you do things out of order, it's not going to work. The same as, let's suppose you had 3 times 4 plus 5. Well, it makes a big difference whether you do the 3 times 4 first, getting 12, and then add 5 for 17, or do the addition first, have 9, and then 3 times that is 27. Well, We know that this is supposed to be 17 because we understand the order of operations. Order of operations matters here too. And you want to be close to the x while you can. Start as close to the x as possible and then move out. Okay, one more. This time we do have both a multiplication and, well, not an addition. I'm just moving to the right. Now, well, let's add an addition too while we're at it. Okay, so I need to start close to the x. So the first thing I'm going to do is this move right. Then my choice is between the multiplication or the addition. We do multiplication first because that's how our order of operations works. So then that, and finally the addition. Okay, so our step 1, we don't have a step 0, it's given to us. Step 0 ordinarily would be one of our pet graphs. Step 1, move right 3 units. Step 2, stretch, a vertical stretch. And step 3 will be up 1. I'm going to have to erase all this stuff so that we can do that. Okay. So, first, to the right 3. Okay, now stretch everything to, I'll use a second color for that, stretch it to, the zeros stay where they are. Again, I'm going to run off the screen with the vertex of this bit that looks like a parabola. Okay, and now add 1. So a vertical slide of my new stretched out shape. That's still not going to bring the vertex into view here. It goes from -8 to -7, and I just haven't got that much. Now if we added 1 before having done this, I don't know where that guy came from, before multiplying, then we would multiply the effect of the adding 1 also. We would have completely different zeros. It just wouldn't look right at all. That's just an error. Okay, so I hope this gives you the idea. It sure is fun to do it on this tablet that I'm using. That's all.